All right, so I'm Iris Classon, all the way from Sweden. Funny story though, I actually didn't know if Dan knew when he booked me that I'm actually born in Romania. It would be sort of funny if they were thinking like, okay, we have this budget and we can only afford like 4 international speakers. We want to make them exotic. Let's get the Americans, they're funny, they're easily entertained. Let's get some Brits, they're not easily entertained, but they're funny to watch. And let's get the Swedes, because I don't know why. And then I come and servus. Well, okay, but my Romanian is actually really, really bad. We moved to Norway in 1989, and I haven't spoken Romanian since then, more or less. But I will tell you one funny story though. And there will be a few stories in this session, just to sort of keep your attention here on stage. So I'll just introduce myself really quickly. My name is Iris Classon, and I'm a software developer at Play. Play does smart home solutions. I was going to show you one of our buttons, but it's in my bag, and with these heels, I don't think I can get back up on stage again unless I walk really far. I'm a Microsoft MVP. I like to write books. I write comedic fiction about programmers, and I write technical books. I have 2 of them coming out with Apress this year, and I write children's books as well. So the drawings you see in the slides, these are my drawings, so yes. All right, do we have a couple of minutes for a funny story? Okay, awesome. All right, so anyways, last time I was in Romania was when I was 16 years old. So we moved to Norway in 1989, basically to just, you know, Ceausescu and all that. So we planned the escape for years. And then, of course, as soon as we get to Norway, he's gone. So we could have waited just a little bit longer and I would still be here. But anyways, we used to go like once a year to Romania, just a quick holiday, and we did it when I was a kid. And then we didn't do it for many years, but when I was 16, I went to Romania together with my mother. She had a brilliant idea to save money on a dentist by me going to a Romanian dentist. And that is a completely different story which I will not recommend. It was cheap, but turned out expensive. But while we were in Romania, we decided we wanted to go out dancing, because we love to dance. So we grabbed a taxi, and we sat in the taxi, and we told the cab driver, well, I told him, because Mom wasn't paying attention, and in my broken Romanian, I was like, eu vreau să merg la cel mai bun nightclub in oraș. And the cab driver, this is in English, is like, please take me to the best nightclub in this very large city. And he was like looking at us, me, my mom, back and forward, and was like, är sigur? And I was like, oh my god, he's asked us, are you sure? And I was thinking that he was thinking that my mom was a bit too old to go out clubbing. So I was like, yeah, nightclub, now. So he was like, all right, and he drove far out into the forest. It was like completely dark, and then there was this lone house, I swear to God, it was just one house, and there was this light flooding out from the windows, and he was like, nightclub. I was like, okay, we go out after paying him, but he doesn't drive off. I was like, okay, maybe he's having a cigarette. And we go in, and there's like smoke machines and light and a lot of beautiful ladies, and they're all undressed. I did not know that nightclub is like a strip club. So I run up the stairs after my very first and last experience going to a strip club with my mom. And the cab driver, this asshole, still waiting there, the cab door open, laughing his ass off as we get back to the cab. And he turns around and says, discoteca? Yeah, that doesn't need any translation. So anyways, I'm here to talk about design patterns. So Microsoft really likes design patterns. And when they did the rewrite of the .NET framework to .NET Core, which is not .NET Core anymore, and I really should be doing a separate session on Microsoft and how they name things. I hope they do not have children. Because they're naming, they were like, you get a new name every year. And nobody knows what to call you. But anyway, so I'm just going to refer to it as .NET, but when I say .NET, I mean .NET Core, the new .NET, the much, much better version, and it genuinely, honestly is. Partly because of, yeah, open source. If you want people to contribute, you gotta have code that is flexible, maintainable, accessible, testable, and all the blah, blah, blah. And also because they have a lot of small teams, they have a lot of teams, and to make it easier for the teams to collaborate, why not, when you rewrite, make it really nice? So they became much more opinionated and vocal about the use of design patterns that are considered best practices. And one of the patterns they really like, and I mean, all these patterns they've used before, but they're just more prominent right now. And one of those is this one, which is the builder pattern. And you probably use something if you write. How many here are .NET developers? Just so I know for reference. All right, so we have a few. So there's the string builder class, which is, I don't see a lot of people using it nowadays because there are so many ways to manipulate strings now, but the string builder is still alive and thriving. But you have the string builder, for example. But now you have the builder at the very core of the application, at the application startup. You have a builder in ASP.NET Core, you have the host builder. And the builder pattern is basically it's a creational pattern, and it's a way to construct complex objects with very flexible step-by-step process, like the Lego bits I drew here. So you're sort of building, and at the very end you go build, and it like ta-da, comes with the full thing, the complex object you build. It's like when my 3-year-old builds something, he builds the most horrible things, like the pieces do not even fit together. It's just pure force and violence and saliva that keeps everything together, but he's so proud. So he's not much of a builder, but he does understand the process of building and doing the final build call where you get to objects. So he will not give it to me until he is done, regardless of how it looks. So this is an example of the builder pattern being implemented. So you have use service provider factor, use and long. So the way you call the methods, this is obviously a fluent interface method chaining, and I'll get to that very soon. But basically you could have different methods that pieces together your complex object. And at the very end, when you're very happy with your sort of building, you just call build, and then you get the final object. If you didn't have something like this, it would probably end up looking like this, like with a constructor with a lot of parameters. I'm not saying that all classes with a lot of constructor parameters should be using a builder class, but this would be an alternative and not a very good alternative. The problem with having a lot of constructor parameters is it's very unclear what they actually do. Even if you use the parameter name in front of them, it's still unclear what happens. And some might argue that you shouldn't have to know what happens, but you do. As a programmer, you want to know what the class does and how it does it. And it's very unclear if you just have a class and you're just shoving in a bunch of information and it looks something like this. I was trying to find which class in .NET has the most parameters, and I was not surprised when everything, I asked ChatGPT, and everything pointed in the direction of all the SQL and ADO classes. So that's where you find a lot of parameters. And honestly, the SQL parameter class probably could benefit from a design pattern such as the builder pattern. Or would it? I get back to that, why maybe it wouldn't. So the benefits is you separate the construction from the actual object, which is really nice. If the object is complex and you have the construction of the object inside of the class grows and it does a lot of different things, which also means that it's a bit sensitive to change. It sort of ruins readability. it makes it less flexible, and as soon as something is less flexible, it makes it also harder to test. And then again, you also have classes where you want to make them immutable. You don't want changes to be made after an object has been constructed. So, when not to use, and this is where I was talking about maybe not with a SQL parameter class. Because if you have mandatory parameters, it doesn't say that if you have a person builder and it has several mandatory parameters, if you don't have those in the constructor, how do you know they exist? You can't make method calls mandatory, not like this anyway. And the same thing if you have a very simple object, it's sort of overkill to use the builder pattern. And if you don't have a need for a step-by-step process, don't use it. So I talked about the fluent interface. So as you can see, I've actually used the examples here. They're made up, and you see sometimes it uses set or add or use. It doesn't matter what you call the methods or what you prefix them with. It's still the concept of creating, because it's a creational pattern. So it doesn't matter what you name the creation process. You're adding or using, but you're doing something anyways. Now you can see what it uses, like in these examples, you see a fluent interface. A fluent interface is when you do method chaining, when you do dot blah blah blah, dot blah blah blah. You're not like pulling out the result every single time you call a method, you chain. And that method returns the same object, returns this, and that's what enables the method chaining. And the way a lot of builders work is that you have the builder, and then you have the builder process. The methods that you call are often extension methods, and you will see that with a lot of the Microsoft builders. And I do believe I have an example later on. Some people say that this is very similar to the composite pattern, which is a structural design pattern, where you also compose objects, but the difference is with that design pattern, with the composite pattern, you compose a particular type of objects that usually have a tree-like structure. For example, say UI components that are several levels deep. So the builder pattern wouldn't accurately sort of describe that building process. And this makes me think about the handler pattern, and I put it in quotations because you see a lot of design patterns that are sort of only accepted as design patterns in the Microsoft or the .NET sphere. Doesn't make them less real, it just means that they make more sense in that context. Anybody here who does the .NET MAUI development? Your hand is like, yes! Ouch, on my shoulder. Like, yes! I love the pride. So I guess you didn't start early on, because you wouldn't be as cheerful if you started a year or two back. At Play, we're actually migrating from Xamarin Forms to .NET MAUI, and oh boy, that's deep. I need more glasses of wine to tell that story. Anyways, the handler pattern is something you see in .NET MAUI. It's very, there particularly, it replaces the renderers we had. So in Xamarin Forms, when you wanted to have a platform-specific implementation or presentation of a control in the user interface, you would use something called renderers. And the renderers would be called before the UI is presented to the user, and you could do your own magic depending on the platform. And Android in particularly always required special solutions. I spent so much time with renderers on Android. And the same thing goes with handlers. Now, handlers is a similar concept. I don't know why, it just feels like it's thinking I'm talking too much. So the handler pattern is very specific to, at least in this presentation, it's specific to the .NET MAUI, and it abstracts the platform-specific UI handling of controls in .NET MAUI. And as you can see in the drawing, so you have the boxes, say there are buttons, and they're all generic, looking the same. And then they pass through the different handlers, depending on which platform you're compiling for, and you get a different result. that's how it works. The code is not as beautiful as a drawing. Now, I've never been a fan of conditional compilation, yet here we are. I was a massive fan of portable class libraries. Crickets, yeah. That explains why my pluralsight course was never very popular, but I was so invested in portable class libraries, and I was proud of never using conditional compilation. Would use some other solutions instead. But now we're back to conditional compilation. Basically, these are preprocessor directives that are defined in your project file, and when you compile your application, it will only include whatever platform you're targeting. So with a handler, you could either do it like this, and as you can see, the button handler has a connect handler method, and inside it you get the access to the native view, which will differ depending on the platform, and then you can do your magic there, but it's the same button, right? If you didn't have that, you would have something like this. And you might be thinking, well, this is the same. It's also an if-else. It's not conditional compilation, but it's still an if-else. Now, there is a significant difference because we are newing up the buttons here, as you can see. So that's the handler lets you change only what you need to change, but it's still the same control. So less code, more flexible, more maintainable. Now, I'm not covering the concept of mappers, but if you're doing .NET MAUI development, you really should look into that. Now, there's always so many patterns that are similar to another pattern. And here is the chain of responsibility pattern, which sort of reminds, like the handler pattern, a lot of people confuse those two, but it's not the same thing. Chain of responsibility pattern also uses handlers, but it's not the .NET MAUI handlers we're talking about. Chain of responsibility pattern manages requests, and it goes through a series of potential handlers that decide when to process it or what to do. I'll get back to this later on. But before I do, a quick mention of the code sample I had a bit earlier. Did you see the native view touch up inside? Like that's a weird name. I had to look it up. So it's because you're touching the button and it's on the way up, so it's key up and it's inside, like inside the control. I don't know what the option would be, like why would you know tap outside, but that's why it's called touch up inside. Quirky little thing. So I talked about portable class libraries and how I was very proud of never using conditional compilation because that was beneath me. I was very young and naive back then. But I did use something called adapter pattern, which is also easy to, let's see, I think I know what the problem with the slides is. I think it's the clicker that actually just moves on the slides after a set amount of time. The adapter pattern is not the same thing as handler pattern. It's actually quite different. Adapter pattern allows you to sort of shoehorn in something. So if you have two incompatible interfaces, you make them adapt to a third interface that they have in common, and then you, by dependency injection probably, inject them in. So this is an example of code. So you have a console logger and a file logger. The way they log is differently. They have two different methods, one called log to console, the one called log to file. You create an iLogger interface that just logs and doesn't care how it does it. And then you create an adapter for each class. And then you register the adapter with the interface. But sometimes some things cannot be forced to fit together. And there is a little bit of problem with some of the design patterns. It's very easy to become enamored, fall in love with the pattern, and want to use it, and sort of force the usage of it. And the adapter pattern is one example. I need to turn this off. I don't know how I turn this off. It's auto-playing, that's why. All right, so let's talk about the next pattern. I'm going to talk about intersecting filter pattern. It's a mouthful, I know, but I want you to think of it as brewing coffee, but you have several filters. It's water pouring through, but each filter adds something. It adds coffee, it adds actual filtering, it adds milk, it adds flavor, aroma, and so on. Intercepting filter pattern, it intercepts and it modifies the requests and the responses, so it's a two-way thing. It's an important distinction from another pattern we're going to talk about. And you see this a lot in action filters. If anybody here does ASP.NET Core development? Right, a few. So we have action filters, and action filters will process a request and a response, and you can provide logic before and after an action executes. And to intercept basically means to catch something or stop it before it proceeds. I intercept my children a lot on their way to the kitchen, on their way to the snack cabinet, and so on. So that's what intercept means. Now, if we didn't have that, it would look something like this. So, before and after the action executes, and then you basically see everything is tightly coupled and everything is in the same place. You might be thinking, nice, I like everything in the same place because I can see it and it's there. The problem is it's tightly coupled, and making changes can be really hard, and it's hard to extend as well. And something like this can very easily just grow and become difficult to manage. So that's why we use filters instead. And what's really great about using filters is you layer them. So you have several filters, but they don't need to know about each other. And that's why it's called intercepting filter pattern. When to use it? Well, obviously, when you need to process at different stages before a request is done and over with, or a response. When not to use, if you have a very simple request response and you don't need filtering, obviously don't use filtering. Now, remember when I talked about chain of responsibility pattern? I didn't show a code example because I wanted to show the code example next to the previous code example, because I wanted to see the difference between the two. So the chain of responsibility pattern, it passes a request through a chain of handlers. But the difference from the intercepting filter pattern is it doesn't do the whole pre-process and post-process, and it's not bidirectional. So there is a significant difference. Filters are applied in sequence, and they're usually for cross-cutting concerns. So the previous code, this is how it would look. So you would get a lot of nested methods, which in the early day of middleware we did see something like that. I don't mean to rush it, but my slides just continue and I do not know how to turn it off, so I'm just trying to join the ride. So we have now the provider pattern. Since we're talking about ASP.NET Core, we're going to talk about something called the provider pattern, which allows you to abstract the process of providing something from the process of actually getting it and configuring it. This might sound a lot like dependency injection. I'll get back to that later. But basically, it's like the drawing here. So you have water pouring out of a faucet and a big tank. And assuming you just assume the water is clean and filtered, maybe by filters layered on top of each other, it doesn't really matter where the water is coming from. It's coming from different providers, but it's all running through the same faucet. And that's the idea of the provider pattern. You attach a lot of providers, and it could be logging providers that you want to log to different logging sources, or it can be configuration providers. You want to add configuration from environment variables, or from an XML file or JSON file, and so on. But you don't know where it's coming from, and it doesn't matter because you get everything the same way. And this is how the configuration provider, how you add configuration providers in, for example, ASP.NET Core, but it's basically the same in any .NET, newer .NET applications. You use the configuration object and then you just add. And all the add blah blah blah, as I talked about earlier, those are extension methods. You can add quite a few different configuration providers. Here is a list of the ones I can remember having used. I'm sure there are more, and you can also create your own custom configuration provider. But the idea is that when you want to add configuration to your application, you don't need to care about where it's coming from. You just add everything into the same bucket. And when you're getting water from the bucket, it doesn't matter how it got there. It's there. Whatever was poured in, you can grab it out. Because if you didn't do that, you would have a switch statement or an if-else statement, and you would have to check, does this exist? Does this exist? And so on. And that's a lot of code, and it's not very maintainable, and it's also not very testable. It makes it very difficult to mock something like this in tests. But configuration providers are very easy to mock. And testing, it's the essence of what we do. All right, so again, the provider model, really? I should have added the link to this article. It's quite old. What is it? 2009. It was updated in 2023. I cannot see what he updated. I don't know, maybe he added a line at the very end. I changed my mind. It's a real pattern. But anyways, some people are really annoyed with the design patterns that Microsoft claims are design patterns. And what are design patterns? Well, it's just common solutions, reusable solutions to very common problems. So we give them a name. And why do we give them a name? Because we're programmers and we love naming things. But we also give it a name because it makes it easier to communicate what we are trying to do. Because it's very hard to read somebody else's logic and to follow it. So if you use a specific pattern, and usually the pattern name will be a part of the object name or the class name, and that communicates what you're trying to do, whether or not you're succeeding. At least this is what I'm trying to do. So anyways, this guy Justin was arguing that the provider model pattern or provider model is more like the strategy pattern. And it's true, it is. But the strategy pattern it's a little bit more abstract and encompasses a bit more than what the provider pattern does. The provider pattern is very specific. And with the provider pattern, you often see, at least in .NET, you often see it combined with something called the options pattern. And options pattern provides you strongly typed access to a group of related settings, which is really nice. I like typed access. And using the same drawing as before, so you have the faucet, you have the water running out, you don't know where the water is coming from, it's coming from different sources, probably, but you only care that there's water. But you might want to have the water in different types of containers, different types of shapes. And that's where options come in. So you want to, if you use, for example, a configuration provider, and you want to grab your configurations, you want to have them as a type. Database options or security options, obviously using a key vault configuration provider for that, but everything is typed. And you can have several types, not just one, and they can be nested as well. Here's a very simple example. I define my options, and when I want to use the options, I use the service collection. Now, in the home controller, in that class, I'm using dependency injections to inject the options and grab them, but it basically uses the service collection underneath the hood anyway, so those two examples more or less do the same thing. But you see the more manual way of fetching configuration, the services configure my options, get section, and there we go, the magic string, which is usually what you want to avoid. So when you use these strongly typed options, obviously the naming has to match the actual options, and there are ways to sort of manipulate and force that to fit other sections. But anyways, how would it look like without it? Well, talking about magic strings, which is an anti-pattern, although it sounds really fun, magic strings and magic integers. We call them magic because it's quite often we do not know what they do, how they appear there, and why they're set to that specific value. And this is an example. So to grab the options, you have to go directly to the configuration, and you have to grab it by using a string. Now you could be a little bit smarter about this and have a massive file called config constants, and everything there will be fields set to name of and the field name. So you could always do that, but that file is going to grow and get bigger and bigger, and it's not strongly typed. It's just a way to avoid magic strings. At least, if you make a change there, that change will be propagated everywhere, obviously, and you don't have the magic strings. But it's still not quite as beneficial as adding an extra abstraction layer by strongly typing options, which also can be mapped to interfaces and so on if you want to further layer abstractions. Obviously, by using the options pattern, it also makes testing so much easier. And it's quite often when you do testing, if you want to do unit testing of API calls and so on, you certainly want to go ahead and mock some of the configuration that you provide in your app. So you can do that by mocking configuration providers, but you can also do that by mocking the injected options in a class if you're using it like that. But again, options pattern? Really? Is it a real pattern? Doesn't sound like it. It's a bit too simple. It does just sound like dependency injection and the service registration. Map this to that. I guess you could argue it is, but it is actually a real pattern, and Microsoft has a longer section on the Microsoft Learn where you can read about it, and it basically just goes through what I'm talking about here. It's all about separation of concerns, which tends to be the cause, the commonality between all design patterns. And you want to separate, you want to have a separation of concerns. And there are so many patterns. This was one of the patterns I did not include in this session. I was going to talk about YARP. Are you familiar with YARP? Yet another proxy, yet another reverse proxy. So I was going to talk about reverse proxy pattern and proxy patterns in general, but I had to skip that because there are so many patterns. And if you want to have fun with patterns, and you can stay alive for just a couple more minutes, I'll give you access to this really simple game. Do not look at the code. I do not write JavaScript, and you can tell if you look at the code, but I'll give you, you can have a look later on. I do want to end this session, because I do know that like 90% of what I've said is not going to stick, because it's a lot of information. I've just walked around on the stage, fighting the clicker and saying patterns, 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 so it's not going to stick. I found design patterns, to be really hard to understand when I studied. Basically, they gave us a book, Head First, Design Patterns, and it abstracted the concept of design patterns so much that the builder pattern, if I remember correctly, was explained as making hamburgers. And I was so invested in this fast food store that made hamburgers that I was just hungry at the end, and I didn't know anything more about the builder pattern. Something about assembling hamburgers. It's a great book for those who are very visually inclined like that and like that type of like metaphors. But for me, it didn't work really well. What has worked best for me in terms of understanding design patterns is not by memorizing them and forcing them in every single solution. I'll get to that very soon, how that ended up for me, but by reading other people's code. And when you do that, you want it to be good code, and I'm very happy to say that looking at the rewrite of .NET is actually very pleasant reading. So what you can do is you can go to GitHub and you can have a read, but where do you even start? So you have something called GitHub Code Search, and it's actually quite clever. You can provide it, for example, you can do a symbol search. So you can say, I want to search for any symbol, like a class or method that has builder in the name. Because if it's a builder, it probably ends in the name with a blah, 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 builder. So you can do that, and you can have a look at the code. In a lot of interactive development environments, nobody says that, IDEs. In many IDEs, such as Rider or Visual Studio, you will have the go-to implementation feature where you right-click and you can have a look at the implementation. That's a great way to take a look at code, but you already knew that. What you can do is combine it with, this is completely unreadable, but you can combine it with some sort of AI assistance. I know there's been a lot of talk about AI and we're probably getting a bit tired of it, but I do want to highlight this. So in this particular screenshot, I am using Rider AI Assistant, and I've highlighted, I first went to implementation of the string builder, I highlighted the class, and then I asked Rider, what is this? What does it do? And you can seriously ask like that. I love it. I try to always be polite in case AI comes back to like kill us off. At least like, you know, like, I was nice. I was asking a lot, but I was nice. Anyway, so you can ask, what is this? And then you can further ask which design pattern is dominant here. And it is blah, 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 build a pattern, composite pattern, decorated pattern. And then you can have a conversation about it, ask for examples, and then go like, I want to implement this in this class, how do I do this? So this is a great learning tool. There's a plugin for VS Code called Augment. I was in the alpha program, tester program, and Augment, in comparison to a lot of the other AI tools, will actually read the whole code base recursively. So it will take a look at all the files. I pulled down the .NET MAUI repository and started asking questions. And I even started feeding it issues that were unresolved in the GitHub repo to look for solutions. And it works incredibly well, and it's a lot of fun. But most of all, it's a great way to learn. So here again, please explain how this is implemented, blah, 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 and you can have a conversation. But I shall not forget to mention Copilot, which is built into GitHub as well. So whenever you're looking at some code, you will see a tiny little drop-down. I actually don't know what the icon is. It looks like a frog, like a frog's head. It's probably not, but that's how it looks like. Anyways, and you can ask, and you don't have to be nice even. You just go like, explain. And it will go ahead and very politely explain. And then you can ask follow-up questions, which is really nice. So that's a nice way to learn more about current usage of design patterns. But there is one more pattern I want to add before I end my session, and it's the most important pattern, and I am personally an expert at the over-engineering pattern. We've all been there. When you create an overly complex solution, when it just could be so simple. And I got this fantastic email after interviewing for, okay, I'll say it. It's in one of my books, The Copy-Paste Developer. You can read the full interview there. I interviewed for Redgate. This is the reply I got to my solution. Code functionality is correct. Yes. This is like a shit sandwich, you know, you start with something nice, you give bad feedback, and then you end with something nice. So, nice, code works, it compiles, great. I did test before I sent it actually, but it's not quite to the level we would expect, blah blah blah. We're not able to consider you further for software engineer role. It's quite verbose with a complicated control flow. My advice would be to simplify. And I swear that that email changed my outlook on how I program quite a lot. That's when I understood that, because they have really good software developers there, and I thought they wanted complex. They wanted to see my brain in code, like, this is the most complex stuff I can make. No, they want something functional, and it's only as complex as needed to execute whatever it's supposed to do, and be maintainable and flexible and all that stuff. So, with that said, if you want to play the game, you can scan the QR code. The link is pretty easy, it's just my GitHub bio patterns. And yeah, I played battery roulette with my laptop and it's about to die and I have 1 minute left. So, 30 seconds left. So with that said, I'll see you at the club. Thank you.